Understanding AI agents, conceptual framework of large language model, LLM-based agent. The conceptual framework of LLM-based agents unveils an architectural masterpiece inspired by human cognition and environmental adaptability. This framework serves as a blueprint for creating intelligent systems that mimic the intricacies of human thought, perception, and action. At its core are three interdependent components: the brain module, which functions as the intellectual hub, the perception module, which acts as the sensory interface, and the action module, which bridges cognition with interaction. Together, these components enable the agent to process information, make decisions, and engage dynamically with its surroundings. Much like Darwinian principles of adaptation, this framework equips agents with the tools to evolve and thrive within complex, real-world scenarios. The brain module lies at the heart of this system, performing tasks akin to a human's cognitive center. It is powered by LLMs capable of reasoning, problem-solving, and memory management. For instance, when tasked with forecasting weather conditions, the brain module synthesizes inputs such as meteorological reports and contextual data, leveraging advanced reasoning techniques to derive conclusions. This central component showcases adaptability, drawing upon stored knowledge to tackle unseen challenges. Beyond processing text, the brain module orchestrates complex action plans, making it the driving force of the agent's decision-making abilities. Complementing the brain is the perception module, which mirrors the sensory systems of humans. This module allows the agent to interpret its environment through various modalities: text, images, sounds, and potentially even tactile inputs. Consider a scenario where the agent predicts rainfall. The perception module processes radar images, auditory weather alerts, and textual data to provide a holistic understanding of the environment. By enabling the agent to analyze multimodal inputs, this component enhances its ability to address real-world complexities effectively. The action module serves as the embodiment of the agent's decisions, translating cognitive outputs into meaningful actions. It is analogous to human motor functions, executing tasks such as sending alerts or manipulating objects. In the rain prediction example, this module might notify users to carry umbrellas or adjust settings in a connected smart home. The action module's capacity to adapt and provide feedback forms a dynamic loop, ensuring continuous improvement and refinement of the agent's capabilities. This intricate framework functions as a feedback system, wherein perception informs cognition, and cognition drives action. This iterative process allows the agent to learn from its interactions and refine its performance, making it a versatile and resilient solution across applications. Whether in healthcare, autonomous vehicles, or educational tools, the modular design of LLM-based agents ensures adaptability and relevance in diverse domains. Brain module, the cognitive core of intelligence. The brain module is the crown jewel of LLM-based agents, embodying their intellectual essence. It orchestrates reasoning, memory management, decision-making, and planning, functions that parallel the complexities of the human brain. This module is not only the agent's processing hub, but also the reservoir of its learning and adaptability, enabling it to tackle diverse challenges and provide intelligent responses. The brain module's foundation lies in its natural language processing, NLP, prowess, which allows it to interpret, generate, and engage in rich dialogues. LLMs like GPT-4, Llama, and T5 empower the agent to maintain multi-turn conversations, retaining context and producing contextually accurate responses. This conversational depth enables the agent to interpret explicit commands and infer underlying intentions, enhancing its interactivity and utility. Knowledge management is a hallmark of the brain module, encompassing linguistic, common sense, and domain-specific expertise. From crafting multilingual sentences to diagnosing medical conditions, this module excels at applying its vast repository of information. However, maintaining the accuracy of this knowledge necessitates continual updates and integrations with external tools to address limitations like outdated data, or hallucinated outputs. Memory plays a critical role in the brain module's functioning, akin to the role it plays in human cognition. The module stores past interactions and observations, using this historical context to guide future actions. Advanced techniques like transformer-based memory expansion and vectorized storage optimize this capability, ensuring relevance and efficiency in memory retrieval. Reasoning and planning form the cognitive backbone of the brain module. Through structured techniques like chain of thought, COT, the agent performs logical deductions, enabling it to solve problems step by step. Planning complements this by breaking down complex objectives into actionable subtasks, allowing the agent to adapt dynamically to evolving scenarios. Perception module, gateway to multimodal understanding. The perception module is the sensory interface of LLM-based agents, designed to bridge the gap between data and understanding. Just as human senses provide insight into the world, this module enables agents to process and integrate inputs from multiple modalities, including text, images, and audio. Text perception is the cornerstone of the module, allowing the agent to parse instructions, infer intent, and engage in nuanced communication. Advanced reinforcement learning techniques equip agents to discern implicit meanings and respond accordingly. This foundational capability is enhanced by instruction tuning, enabling the agent to generalize across tasks with minimal retraining. Visual perception adds another dimension by allowing the agent to process images and videos. Through techniques like image captioning and vision transformers, VET, the agent translates visual data into textual descriptions for analysis. This multimodal ability is further refined by integrating temporal understanding, as seen in video analysis models. Auditory perception completes the triad of sensory inputs, enabling agents to process speech, environmental sounds, and alarms. Models like Whisper facilitate tasks such as speech-to-text conversion and audio classification, enriching the agent's situational awareness. The perception module's future lies in expanding to novel modalities, such as tactile feedback and environmental sensing. By incorporating richer sensory data, the module will allow agents to operate in increasingly complex environments, from autonomous navigation to healthcare monitoring. Action module, enabling interaction and impact. The action module is the agent's bridge to interaction, transforming its cognitive outputs into tangible effects. This module enables the agent to act through text generation, tool usage, and embodied physical actions, creating a spectrum of possibilities for real-world applications. Textual action remains the primary mode of interaction, with LLMs generating coherent, contextually relevant outputs. From drafting emails to holding engaging conversations, the agent's linguistic capabilities underpin its versatility. The integration of tools extends the action module's utility, allowing agents to perform specialized tasks, such as database queries or mathematical computations. By learning tool functionalities, agents can dynamically select and use the appropriate resources to solve complex problems. Embodied actions, such as object manipulation or navigation, represent the frontier of LLM-based agent capabilities. By simulating physical interactions and refining these through feedback loops, the action module paves the way for agents to operate in dynamic and unpredictable environments. As these modules evolve, they will continue to redefine the boundaries of AI, creating systems that are not only intelligent, but also deeply integrated into the human experience. Through the harmonious interplay of brain, perception, and action, LLM-based agents are poised to revolutionize industries and transform the way humans interact with technology. For more details, please see the reference, The Rise and Potential of Large Language Model-Based Agents, a survey, https://archive.org/abs/2309.07864